Good afternoon. We are going to take notes on 7.4, which is working with similar triangles. We're basically going to take what we've learned about similarity and put it to work on some triangles. All right, part A, definition of similar triangles. Two polygons are similar if their vertices can be paired so that, number one, corresponding angles are congruent, and number two, corresponding sides are in proportion. Their lengths have the same ratio. Okay, by using the definition, we're going to find the sides, the angles, and the scale factor of these two figures. All right, given ABC and triangle A prime, B prime, C prime. If the measure of angle A is 48.6, the measure of angle B is 41.4, find and label the rest of the angles on both triangles. Okay, well, if we use triangle sum theorem, we can take two angles and find the third one. 48.6 plus 41.4 plus angle C equals 180. And I'm not going to go through the solving, but we get angle C is 90 degrees. This means that C prime is also 90 degrees because in similar figures, the angles are congruent. So if A is 48.6, A prime is 48.6, B is 41.4, B prime is 41.4. So the angles are the same between the two figures, but one is obviously bigger than the other, so we need to find a scale factor. All right, problem number two. If B to C is 6, let's label that. B prime C prime is 3. AB equals 4, and A prime C prime equals 4. Find and label the rest of the sides on both triangles. Okay, so in order to find missing sides of similar triangles, we first need to find a pair of matching sides. So BC and B prime C prime are corresponding sides. And to find the scale factor, we're going to do old over new or original over new. In this case, ABC is original and BC is 6. A prime, B prime, C prime is the new one. B prime, C prime is 3, which reduces to 2 over 1. That is our scale factor. Okay, now we can use the scale factor to find the other sides. So let's find A prime, B prime. So you put your scale factor on the left, which is old over new, and then you put your side lengths on the right, old over new. AB is old, so that's 4. New is A prime, B prime. And that gives us an equation that we can solve. And I'm just going to put dot, dot, dot. We do find that A prime, B prime is equal to 2. Let's label that. There we go. All right, so now we need another equation to find AC. So put your scale factor on the left, old over new, 2 over 1. And then AC is the old side, which is what we're trying to find, over the new side, A prime, C prime, which is 4. That gives us our equation to find AC. And I'm just going to put dot, dot, dot again. AC ends up being 8. So we have solved for the missing sides using the scale factor. All right, part C, using the definition, prove two triangles are similar. Okay, working the problem backwards to prove that triangle ABC is similar to A prime, B prime, C prime using the definition of similar triangles. So the definition of similar triangles. If we use the definition, we have to show that number one, corresponding angles are congruent, and number two, corresponding sides are proportional. Okay, let's start with corresponding angles are congruent. From the drawing, the measure of angle A is equal to the measure of angle A prime, and they are both 48.6 degrees. The measure of angle B is equal to the measure of angle B prime, which is equal to 41.4 degrees. The last one, The measure of angle C is equal to the measure of angle C prime, and both of them are 90 degrees. With those three statements, we have fulfilled requirement number 1. Corresponding angles are congruent. Okay, number 2, we have to prove that corresponding sides are proportional. This is a little bit more complicated than the angles. What we're going to do is create 3 ratios of sides, and then we're going to reduce them to show the same scale factor. If they are similar, all 3 ratios should reduce to the same scale factor. Okay, so here we go. AB over A prime B prime, filling in those side lengths, that's 4 over 2, which reduces to 2 over 1. Okay, so now the second side, AC over A prime C prime. Those side lengths are 8 and 4, and that also reduces to 2 over 1. Last one, BC over B prime C prime. Those sides are 6 and 3, and those reduce to 2 over 1. All 3 of the ratios of sides, old over new, gave you the same scale factor. Therefore, triangle ABC is similar to triangle A prime, B prime, C prime, using the definition. All right, turn the page. Now, of course, we have other ways to prove similarity than just the definition. So here's our first postulate, postulate 15, angle similarity postulate. Notice it is AA with a similarity symbol on it. That's your title. This postulate says if 2 angles of one triangle are congruent to 2 angles of another triangle, then the triangles are similar. So like all theorems and postulates, this is a shortcut to having to prove all the angles and that the sides are proportional. So in this drawing, obviously D and D prime are corresponding angles. They are congruent. And E and E prime are congruent. Now here's why this theorem works. Triangle sum theorem on each of these gives the third angles. And if the first 2 are the same, the third ones will also have to be the same. So all 3 angles are congruent. Therefore, triangle DEF is similar to triangle D prime, E prime, F prime. And we do not have to prove anything about the sides. Okay, so we're going to skip part B. So just put a big X through that and flip the page. And we're going to get into this practice, which is more similar to what we're going to be doing. Okay, so your mission is to tell whether the triangles are similar or not similar. Okay, so number 1, we have a triangle here. So we have a big triangle and we have a little triangle. So here's the little one. And the big one contains the little one, just like that. So looking at this, if we use the theorem, we only have to prove that 2 angles are the same. All right, well, this is the easy one because it's shared between the 2 triangles. And that would be reflexive property. Because an angle is congruent to itself. And then to get the second angle, we have 2 parallel lines crossed by a transversal. This angle here on the big one and this angle there on the small one correspond. And they are both upper right, upper right. So if you have 2 parallel lines cut by a transversal, I'm going to abbreviate that, corresponding angles are congruent. So now I've proven 1, 2 angles. We can say, yes, the triangles are congruent by angle-angle similarity postulate. All right, number 2, we have 2 triangles with 1 angle, 2 angle. This one's a no-brainer. Yes, they are similar by angle-angle similarity postulate. We have 2 angles the same. Okay, number 3, looking at this triangle. Well, interesting with this one, we don't have 2 angles. What we do have, though, is a side, an angle, and a shared side, which means by side, angle, side, I can say that the 2 triangles are congruent. So, the fact that they are congruent means, by the definition of congruent, all angles are congruent, and by the definition of congruent, the sides are proportional. And their proportion would be 1 to 1 because they are the same. So because these 2 qualifications were met, we can say, yes, the triangles are similar, and it would be by the definition of similar triangles. So once they're congruent, they are automatically similar. All right, number 4. We have a little triangle here, and it's inside the big triangle. There's 1 congruent angle marked for each, but both of these actually share an angle. So that is congruent in both of them by reflexive property. So we now have 2 angles congruent. So the answer is yes, they are similar by angle-angle similarity postulate. All right, so that's how you tell whether the triangles are similar or not similar. You'll be using reflexive property, parallel line theorems, and congruent triangle theorems. Okay, number 5, find the value of x. All right, so this problem looks a lot like number 1. We know that the 2 triangles share an angle. We also know that with 2 angles cut by a transversal, corresponding angles are congruent. So we already know that the triangles are similar. All right, this allows us to set up a proportion for the sides, because if the triangles are similar, the sides are proportional. Now this one, it might help to draw the little triangle and the big triangle, because we have to do a little math to get the sides. And it's really easy to pick the wrong numbers for sides. All right, so we have a little triangle and a big triangle. On the little triangle, which is this one, we have a side length 3 and 5. On the big triangle, we don't have a left side, but it is 3 and 4. 3 plus 1, which is 4. And this side here is 5 plus x. And we already know they are similar, which means I can set up corresponding sides and equal to each other, and we can solve that. So in this one, there is no old and new, so we just make sure we're consistent. Let's go big over little. So big's long side is x plus 5 over the little one's longest side, which is 5, equals 4, which is the medium side of the big one, over 3, which is the medium side of the small one. That would be our setup, and we would solve from there. All right, find the value of x. Okay, triangle ABC, which is the big one, is similar to, here's the small one. Let's get it in the right order. Triangle, let's see, A and E correspond. B is the same on both, and D and C. So triangle EBD is the corresponding one. We're going to find the ratio of x and the value of x and y, or at least we'll set it up. Okay, so let's do B, which is to solve for the y. We'll do that one first. So looking at between the 2 triangles, y and 8 correspond, so that'll be one ratio. And then we have a 4, and then the long side here, which is going to be 7. So we do have corresponding sides, corresponding sides. Let's make the equation. I'm going to go small over big. So y over 8 equals small, which is 4, over big side, which is 7. That will give us something to solve. It ends up being 32 over 7 for the y. Okay. C, we're going to set up something to find the x. X is this little piece here, which means that this whole side here is x plus 3 when you add it together. So side of the big one is x plus 3 over side of the little one here, which is just 3, equals, so I'm going big over little, and I'm going to use these sides again. The big one is 3 plus 4, which is 7, over the little one, which is 4. And then we can solve. So BE over BA is 3 over x plus 3, and x ends up being 9/4. Notice for convenience sake when you're solving, you can put the variable on top. Just make sure that whether you're doing big over small or small over big, that you're actually doing the same thing on both sides of the proportion. Don't get that mixed up. When in doubt, go small over big on both sides. Just do that all the time and then you'll never be wrong. All right, that is the end of the notes today. Just one simple postulate and a lot of solving. Have a terrific afternoon.